Today, we are diving into a discovery that, and I'm not exaggerating, literally powers our modern world. It's a fundamental force of nature that was hiding in plain sight for centuries. So let's get right into it. I mean, it sounds like something out of a comic book, right? Creating an invisible force just by running some electricity through a wire. But this isn't science fiction. This is the real-world idea that kicked off a massive scientific revolution. And by the end of this, you'll see exactly how it works. So here's our game plan. We'll start with the history, then we'll break down the key experiment that started it all, define the invisible force it uncovered, and finally, we'll look at how that single observation completely changed everything. Now, to really appreciate just how huge this discovery was, we've got to rewind the clock. We need to go back to a time when two of the universe's most basic forces were thought to be total and complete strangers. For, pretty much all of human history, scientists looked at electricity, lightning, static electricity, and magnetism, that weird force that makes a compass point north, as two totally different things. It was like they were two different animals with their own set of rules. Nobody really thought they were connected. Well, that all changed in the year 1820. And the person who changed it all was a Danish physicist named Hans Christian Oersted. The story goes that in April of 1820, he was giving a lecture, and, kind of on a whim, he decided to try a new demonstration right there in front of his students, an experiment that had never been done before. And the setup couldn't have been simpler. He had a wire hooked up to a battery, and he just placed it near a regular magnetic compass. The moment he connected the circuit and let the electric current flow, the compass needle, which should always point north, suddenly jumped. It moved. Oersted knew in that exact instant what he was seeing. That tiny twitch of a compass needle was the proof. It was the first hard evidence that electricity and magnetism weren't separate forces at all. No, they were deeply, fundamentally connected. So what was actually happening in that experiment? How did it work? Let's break it down step by step to really understand the physics behind that moving needle. So picture this. You've got a simple battery. You connect it to a copper wire, but you put a switch in the middle so you can turn it on and off. Then, right underneath that wire, you place a magnetic compass. The needle is just sitting there pointing north like it's supposed to. Nothing's happening yet. But then, you flip that switch. An electric current instantly starts flowing through the wire. And bam! The compass needle kicks to the side. It deflects away from north. An invisible force, created by the electricity, is literally reaching out and pushing the magnet in the compass. And here's the kicker. The second you open the switch and the current stops, the needle just swings right back to its original north-south position. This is so important because it proves a direct cause and effect. The force is only there when the electricity is flowing. No current, no force. Okay, so here's a classic question, the kind of thing you'd get on an exam. Let's say we swap the wires on the battery, so the current now flows in the opposite direction. What do you think happens to that compass needle? Take a second to think about it. If you guessed that it deflects the other way, you are absolutely correct. Reversing the current actually reverses the direction of the force. This is huge because it tells us the force isn't just a random push. It has a specific, predictable direction that depends completely on the direction of the electric current. So let's boil all of this down to the single most important conclusion from Oersted's experiment. The one sentence you absolutely have to remember is this. An electric current produces a magnetic field around the conductor. Oersted's experiment proved this magnetic field was real. But what exactly is it? What is this invisible force? Let's get a clear definition. All right, here's a perfect exam-ready definition. A magnetic field is a region of space where a magnetic force can be felt. The best way to think about it is like gravity. The Earth doesn't have to physically touch an apple to pull it down, right? The force acts across space through a gravitational field. Same idea here. The wire doesn't touch the compass. The force acts through this invisible magnetic field. Now, this field has three key properties you need to know. First, it has a direction at every single point in space. That's what the compass shows us. Second, it has a strength or a magnitude. It can be strong or weak. And third, it's not flat. It's a 3D field that surrounds the entire wire, kind of like a sleeve. And that strength changes. It's just like the heat from a fire. The closer you are to the flames, the hotter it is. Same deal here. If you put the compass right up against the wire, the field is strong, and you get a big deflection. But if you move the compass farther away, the field gets weaker, and the needle barely moves at all. So, an electric current creates a magnetic field. Big deal, right? Well, yeah. It's a huge deal because understanding this one simple principle unlocked a technological revolution that we're still living in today. I mean, just think about it. What's an electric motor? It's a device that uses electricity and magnetism to create motion. What's a generator? It does the opposite. It uses motion and magnetism to create electricity. Everything from giant industrial cranes to the speakers in your headphones, all of it is built on the foundation of Oersted's discovery. And that's really the ultimate takeaway here. Oersted didn't just build a bridge between the science of electricity and the science of magnetism. No, he completely demolished the wall between them, proving they were really just two parts of the same single fundamental force of nature, electromagnetism. And that is the powerful idea I want to leave you with, that a simple, accidental observation of a twitching compass needle revealed a deep, profound truth about how our universe works. Electricity and magnetism are not just related, they are two sides of the very same coin.